All right, this is a typical problem you'd see in a college physics classroom, or in an algebra 2 classroom, or calc, or pre-calc, or any of those type of courses. But what it is this equation here that you would map the height of a ball that you threw up in the air, or a rocket, or if you shot a gun, or shot some sort of projectile up in the air. So the height at time t of an object that is moving in a vertical line with constant acceleration a is given by this equation, this position equation, where s is the height in feet, a is the acceleration in feet per second squared, t is the time in seconds, v sub naught is the initial velocity at time equals 0 in feet per second, and s sub naught is the initial height in feet. So in other words, these, a lot of people don't understand this v sub naught idea. That just means initial velocity. That little subscripted 0 just means that's where we start. So we're going to kind of ignore that as we work into this problem, but just keep that in mind. V with a subscript 0 just means initial velocity if you're in a physics class. So here's the deal. If you have s is 52 at time 1 second, so you'd plug that into this formula. So instead of s here, we'd put a 52. So 52 equals 1/2 a times 1 squared plus v. I'm not going to put the subscripted 0 with it. I'm just going to leave it v. And then times 1 plus s. And again, I'll take the subscripted 0 off. So that's the first set. Now we'll look at the second set. So 52 equals 1/2 a times 2 squared plus v times 2 plus s. And then your third equation is a 20 and a 3. So 20 equals 1/2 a times 3 squared plus v times 3 plus s. And I'm going to rearrange all of these. So to rearrange these, 1/2 times 1 here, that little part, and I should change colors. So 1/2 times 1, that's just 1/2 a. So you'd have 1/2 a plus v plus s equals 52. That's the first equation. Then your second equation, this would be a 4 times 1/2 would be 2. So 2a plus 2v plus s equals 52. And then your third equation is a 9. 3 squared is 9 times 1/2 is 4.5. So you'd have 4.5a plus 3v plus s equals 20. Now to solve these with elimination and things like that, be easier to get rid of the fractions. I try to avoid those as much as possible. So I'm going to multiply this top equation by 2 and this equation also by 2, just to get rid of the decimals. And so what you'd have then for our kind of simplified equations would be, 2 times 1/2 is a plus 2v plus 2s equals 104. That's that top equation. We'll leave the 2a alone. 2a plus 2v plus s equals 52. And then your third equation, we're going to multiply it by 2. So 4.5 times 2 would be 9a plus 6v plus 2s equals 2 times 20 is 40. And so we have our three equations, three unknowns. Instead of x, y's, and z's, we have a, v's, and s's. And so you pick the easiest one to solve for. And you can pick any of them you want to pick. A lot of times I pick the s, because it seems fairly easy. So you would have to multiply this equation by -2 to get rid of that. So your first equation would be A, I'm just going to rewrite the top equation, plus 2v plus 2s equals 104. And then you'd have -4a plus -4v minus 2s equals -104. And so that's these first two equations. And if you add those, you'd have -3a minus 2v. The two s's cancel out, which is what we wanted. And then you'd have 0. 104 minus 104 is 0. All right. And what's kind of cool is you could do the same with these two equations. And so, and to eliminate the s, you could multiply it again by a -2. So it matches with the bottom two equations. That's why I usually pick that s, that one at the end. And so you'd have -4a minus 4v minus 2s equals 104, and that's negative. And then your bottom equation would be 9a plus 6v plus 2s equals 40. And then you add those together, and you'd have 5a plus -4 plus 6 is 2v. The s's would cross out. -2 plus 2 is 0. And then -104 plus 40, we can go ahead and add those two together. And you'd have -64. And then, so now you can just combine your two equations, the green one and this green one here, this pink one here, get those together. And so you got -3a minus 2v equals 0. You've got 5a plus 2v equals -64. And here we can add it together because these v's match up. And so this would be 0 if you add them. You'd have 2a equals -64. And then you divide by 2, and we get the number we're after. So a is, our acceleration due to gravity is -32 feet per second, which is the acceleration due to gravity in feet per second squared, well, squared, there we go, on the Earth. And so we have one of the numbers that you kind of typically see in a physics classroom. And so to find v, then, you just plug that in. And I'm going to plug it into this formula, this -3a minus 2v equals 0. So you'd have -3 times -32 minus 2v equals 0. And so this would be 96 minus 2v equals 0, and minus the 96 over. And so -2v equals -96, and you divide by -2. And we'd have velocity being 48, and that's feet per second. And so now all you have to find is your initial height, which is that s. And so I'm going to zoom out here a little bit, which I just did. And so we have our velocity, oops, there it is. Our velocity is 48. We need to change some colors here. Our acceleration due to gravity is 32. So we can use these two with one of our original equations to find, and I'm going to use the very top one. So a plus 2v plus 2s equals 104. And so we know our acceleration due to gravity is -32 plus 2 times our velocity, which is 48, plus 2s equals 104. And so you'd have -32 plus 2 times 48 is 96 plus 2s equals 104. And so this is, these two here, that's 64 plus 2s equals 104. Then we'd subtract the 64, and 2s equals 40. And so s is 20, because you divide by 2. So in other words, our initial height is 20 feet. So this would be 20 feet. Our initial velocity, so this is s sub o, and our initial velocity is 48 feet per second. And since evidently we're standing on the Earth, our acceleration due to gravity is negative 32 feet per second squared. And so that's that part. And so that's a kind of a basic problem you'd see in physics or calculus or pre-calculus, or you'll see it over and over again. And so let's move on to the next problem, which is what you'd see more accurately in an Algebra 2 class or a pre-calculus class. You wouldn't see this in necessarily a physics class. But it's exactly the same problem as we just got done doing. But instead of s's and t's, you've got x's and y's. And so you're going to plug this negative 1, 3 into this equation. So x is negative 1, y is 3. And so you'd have 3 equals a times negative 1 squared plus b times negative 1 plus c. That's your first equation. Then you plug in the second equation, or second set of points. And so that's 1, 1. So 1 equals a times 1 plus b times 1 plus c. And then you plug in the third equation. And so if you plug in the third equation, it's 2, 6. So 6 would equal a times 2 squared plus b times 2 plus c. And again, with this problem, I would rearrange things and just write it nicer. Negative 1 squared is positive 1. So you'd have a minus b plus c equals 3. So that's that first equation if we rearrange it and put it in the order that you see most of these problems. The second equation here would just be a plus b plus c equals 1. And your third equation, again, that's a 4a, because 2 squared is 4. So 4a plus 2b plus c equals 6. And so there's your three equations, three unknowns. We just want to know what a, b, and c is so we can get these equations. And so most of the time when I do these, I go ahead and get rid of the c. So like on this equation, I would just multiply by a negative 1. And that eliminates a lot of stuff for us. And so I'm going to rewrite the top equation. So it'd be a minus b plus c equals 3. This equation, I would go ahead and multiply my negative. So negative a minus b minus c equals negative 1. And if you add that, notice a minus a is 0. Negative b and negative b is negative 2b. C and c is 0, which is nice. And 3 minus 2, or 3 minus 1 is 2. And so we know b is negative 1. So that's kind of a nice situation. We've got that all taken care of. So now, I'm going to go to orange. We're going to do these two equations. We've got a b. We've got one of our answers. We need to find one of our other answers. And again, I'm going to eliminate my c and keep this a negative 1 here in the middle, because that'll eliminate my c. So you'd have negative a minus b minus c equals negative 1. And again, I'm just multiplying this negative 1 through the whole thing. And then the bottom equation, we'll just leave like it is. So 4a plus 2b plus c equals 6. And then you add those two together. So that would be 3a plus b, because negative b plus 2b is positive b. C's would cancel and equals 5. And so to find a then, you can plug b in. So we can take this b and plug it into that thing. And so you'd have 3a plus negative 1 equals 5. So plus 1, that's 6. 3a equals 6. So a is 2. And we've got 2 of our answers. So now that you have 2 of your answers, we can go ahead and plug those into one of the originals. I'm just going to plug it into this top one. And so we'd have a, which, excuse me, I should have plugged it in, which would be 2. Which would be 2, and then you would, so again, I'm plugging it into this top. Let's switch colors because this is terrible. So we'd have a 2 for a right here. Negative b, well, it's a negative 1. So that'd be plus 1 plus c equals 3. So you got a negative going into a negative. So there's a negative 1 here going into this negative, which would make it positive. So you got 3 plus c equals 3. You subtract the 3 over, and you get 0. And so if you go back to the original, what we were after y equals ax squared plus bx plus c. There we go. And so we know what a, b, and c are. So you can rewrite that equation. So y equals a is 2 x squared plus b is negative 1 x plus 0. So just simplifying it, 2x squared minus x. And there's the equation we were after with those 3 points. And if you plug that into GeoGebra, you plug those 3 initial points in, you plug this equation, you'll see the equation goes through those initial points. And so that's the algebra of what I'm after. So hopefully this helps, and see you next time.